team, it's Mr. Z, and today we're going to continue our adventure with quadratic forms. Essentially, we're going to be looking at connections between equations and graphs. So let's go ahead and enjoy this adventure. All right, standard factored form, vertex form, it's our bread and butter. We're used to it. I just want to go ahead and review about vertex form, this new part about the axis of symmetry and how we go from the vertex to the axis of symmetry. Well, essentially, it can either be concave up, concave down. We know if it's concave up, it's going to have a minimum, and if it's concave up, it's going to have a maximum. With vertex form, you are easily able to identify the coordinates. It's always going to be h, and then it's going to be k. So vertex form is nice because I'm able to, on the fly, just see, hey, what the vertex is. Key point, the vertex does directly lie in the middle of the quadratic, meaning if I draw a vertical line through the vertex, it will always create a line of symmetry, an axis of symmetry. Where is it going to be? At the vertex, at the x part of the vertex, which is going to be h. Keep this in mind. Okay, for number one, basically we got to look at these graphs and see, can they match the equation? So when I'm looking at this first guy, -2, -1/3, I'm analyzing all of my a values. And in order to save some time for myself, I'm going to go ahead and see concave up or concave down. This is totally concave down. So immediately, this is a no-go, this is a no-go, this is a no-go. And I would say on the test, this cannot match because the equation creates a quadratic that is concave up while the graph is concave down. Simple enough. Okay, so we've been able to eliminate about half of the problems. Now we got to see the equations left. Can they potentially be a solution? So for this first one, this is in factored form. Remember factored form, if I solve the parentheses for zeros, they produce, you could ask yourself, what number plus 1 is 0? That turns into -1. What number plus 4 is 0? -4. So do you see how both of these x values are negative? That means that my quadratic is going to have a x-intercept of -1 and -4. This matches my graph. Both of these are negative x-intercepts. Keep in note though, team, even though it's an x plus 1 in the equation and an x plus 4, this is secretly telling me that the x-intercepts are going to be negative. The reason being is if I rewrite the first equation as in factored form, it is going to produce x minus, notice how I'm going to switch to another color, -1, and then it's going to be x minus -4, and voila. I see with my mind's eye, by rewriting it in this factored form up here, I can see that the roots on site are -1 and -4 without solving. That solving bit helps you find the x-intercepts of simplified equations. So this is a good equation. This works out really well. This, I would get paid bougie money to produce an equation for my company. I'm going to go ahead and look at the other factored forms and going ahead and scanning it. We've eliminated all of them. So let's go on to the next one. Standard form. The other piece of information they give us is this -6. Now, it is concave down. And if I extend my graph, it will eventually hit this y-axis. And since it's not labeled, like I can maybe say that this is -6. I have no guarantee that it's not. So this can work. It is concave down. It has a negative y-intercept. So this is good to go. Looking at equation number 6, it is concave down. Now this is a vertex check. What is the vertex? It is going to be, it is an x minus h squared plus k form. Notice how it's written as x minus inside of the parentheses. I would rewrite it if it wasn't. The vertex is going to be 6, 3. Okay, vertex. If I go over positive 6 and up 3, I'm going to be in quadrant 1. Is that true for this graph? No. The vertex is not in quadrant 1. Some of you might be wondering, hey, how do I know the names of the quadrants? Sketch it out and go counterclockwise. 1, 2, 3, 4. Not in quadrant 1, but quadrant 3. Okay, same thing. The next one is in vertex form. It's going to be -4, 5. Okay, let me check this with my graph. I go over 4 and then up 5. This can be a potential. Yes, it matches. The vertex will be in quadrant 3. Okay, this next one, this is an exponential. This is kind of coming the flashback from the past from Math 3. It looks like that guy. Now, since it's going to be negative, it is going to be flipped. So it's going to look like that guy. No, this isn't even a quadratic. All right, this last one, I see this plus sign. This is the biggest lesson from today. On site, rewrite it. If you can do it mentally, more power to you. But watch how I'm going to represent it. I rewrite it as x minus. I bunch out my color to make my vertex form stand out. Squared plus k plus 2. So the vertex is always going to be -5, 2. Is this going to be in quadrant 1? If I start from the center and I go left and then I go up, yes, for the same reasons as quadrant 7. Okay, notice how this practice is going, and it requires you to be proficient with standard factored in vertex form. All right, this next one. For each function below, list the key pieces of information. And we have to figure out which one is going to model the graph. So, modeling the graph. What do I see? I see it's concave up. Scanning my A values, concave up. There's no number here. It's a positive 1. Concave up, concave up, concave up, concave up, concave up. Okay, I can't eliminate any of them based on concavity. Now I have to kind of take a deeper look inside. So let's go ahead and look at this first one. It's in vertex form. And notice how it's x minus a number and k. So the vertex is going to be -75 and -92, meaning I start from my left, I go left, and then I go down. It's going to be in quadrant 3, but the vertex is in quadrant 4. So this is going to be, oops, I made a mistake. This is +75. Notice the big difference in that, x minus 75. So 75 down to -92. Since there's no numbers, this can be a potential solution. The vertex is in quadrant 4, matching the picture. This next one, x minus 8, x plus 2. X minus 8, x plus 2. Solve it. You can ask yourself, what -8 is 0, 8, -2. Now, when I look at these x-intercepts, I notice how they're both positive. This is not going to be the case. Both intercepts must be positive. So that's a no-go. This next one, the vertex is 5, -3. Starting from the origin, I go right and I go down, and this works. It is in quadrant 4. Here, this is where rewriting it in vertex form is going to help. G of 2 of x is going to be equal to 3. Watch what I do. X minus negative 4 squared minus 2. The vertex is going to be negative 4, negative 2. That means if I start at the origin and I go left, and then I go down, it's going to be in quadrant 3, which is a no-go. All right, standard form. I look at the last number and I see it's a 2. And this is, you might be like, well, Mr. Z, 2 would be down here. Technically, I don't know the scale of the graph. And if it continues, it is going to hit the y-intercept. The y-intercept will be positive. So this can be a potential solution. Here, this next one, negative 1, negative 3. I need both of my x values to be positive, so this is not going to be the case. All right, this is the part where we go ahead and write quadratics using key information, basically the backwards of what we're doing. It needs to be concave down, and it needs to be a maximum at this. This is going to be vertex form because it tells us a maximum. This is going to be h, this is going to be k. So my function needs to be called g of x. Let me write the generic form, which is going to be x minus 8 squared plus k. Now, let's fill in the dots. Do we have an a value? Concave down, negative 1. X minus, what is h? Negative 1 squared plus negative 5. Let me clean it up a little bit. Negative. I could drop the 1. It's assumed. Don't expand it. Leave it like so. Vertex form. What a good looking equation. Similarly, write a quadratic function that is concave down, and it has roots at 5 and 7. So meaning the roots are the 5 and 7. The answers are 5 and 7. So let's go ahead and try to create something in factored form. The generic form is going to be f of x is equal to a times x minus root 1, x minus root 2. Plugging the values in, concave down, I like to just keep it simple, negative 1, x minus 5, and x minus 7. You can use Desmos to check to see if this is an accurate picture for number 3 and 4. All right, some review. Factoring. Let's go ahead and set up our area model. Factoring never is going to go away. Don't let yourself get rusty upon it. I'm going to go ahead and see that x squared and 10. And now I'm going to go ahead and start thinking, what numbers multiply to be x squared? What numbers multiply to be 5? Times 2 is 10. Now let me produce my area model. And I got lucky. 5x and 2x does make 7x. So the factored form of this guy is x plus 2 times x plus 5. Again, set up my area model. Immediately I put my a term, and then I'm going to put my b term, x squared, and then 8. Again, x times x produces x squared. Now, look at this b value ahead of time. I see that's a negative number. Remember, a negative times a positive is equal to a negative. A negative times a negative is equal to a positive. And a positive times a positive is equal to a positive. So when I'm looking at the factors of 8, I'm going to pick 2 negative factors to produce a negative b value, but a positive 8. And when I multiply this out, that matches. X minus 2, x minus 4. Okay, looking at this in standard form for this next one, 7. I see it in my mind's eye as x squared plus 0x minus 25. So when I write my area model out, I want my two terms to cancel. Negative 25, I know that x times x is going to be x squared. 25 only really has the factors of 1 and 25 and 5 and 5. So I'm going to make sure that one of them is negative, one of them is positive. So I'm going to get negative 5x. I'm going to get 5x. And notice how they are inverses. The negative 5x and the 5x will cancel out, producing my 0x term, leading me to see x minus 5 times x plus 5. Okay, number 8. Immediately upon sight, I scan this standard form, and seeing the A, B, and C values are all even lends me to do my first step to be GCF factoring. I'm going to divide them all by 2, and this is done so that I can write the 2 in front of my parentheses. And this is going to produce 1x squared plus 4x minus 5. Now, this is a problem in itself. I'm going to ignore this 2, and I'm only going to factor the inside. So when I set up my area model, I can go ahead and put x squared. I can put negative 5. So generating the factors, x times x is x squared. Negative 5 is prime, so it's only going to be 5 and 1. Now, what do I want? I want a positive 4, meaning I'm going to pick a bigger positive value, a smaller negative value, and when I multiply it out, I see that 5x minus 1x is going to be 4x, leading me to my final answer of 2x minus 1 and x plus 5. Okay, a couple more to go. Plugging in if f of n is equal to 3n minus 2. This is a review of how well you're able to evaluate. So f of negative 4, remember I'm placing all inputs of n with a negative 4, is going to be 3 times negative 4 minus 2. Now, let me go ahead and plug some stuff out. Using my order of operations, I'm going to multiply the inside first, and I'm going to get negative 12 inside of an absolute value. The absolute value is the positive version of a number. So this is going to turn into just plain old 12 minus 2, leading my output of negative 4 is going to be 10. All right, similarly, for number 10, this is just a game. Am I being careful enough to go slow? And I see K and I see W. I have to make sure I put the right value in the right equation. And color helps. I clearly see that W is going to be an input for the equation on the right, while K is going to be an input for the equation on the left. So what is negative 3? So I'm going to plug in K of negative 3, and it's going to be negative 3 squared plus negative 3 minus 1. Similarly, W of negative 2 is going to be 4 times negative 2 minus 5. Evaluating this out, this turns into 9. Simplifying plus minus 3 is negative 3 minus 1. Kind of doing both of them at the same time, revealing a negative 8 minus 5. K of negative 3 is going to be 5. W of negative 2 is going to be the absolute value of 8 is just 8 minus 5, which is going to be 3. So the final thing I need to do is multiply these two values. 5 times 3 is going to be 15.